Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqmal bin Jamal Salvi. My number matrix is AA191616 from section 1, control system. So today I will introduce you how to design the open loop control system in Matlab simulator. So first of all, we have to click a Matlab apps. Then we click a Simulink button. Then choose a blank model, which is I already choose it. So it will pop up like this. Then we just save it anything we want. Auto basic. So to create to design the open loop control system, first of all we have to choose a library browser. Click it. So you pop up like this. So we choose a continuous and drag the integrator to this blank space. So there we go. So after we drag the integrator, we choose a inductance, which is math operation. And we take then drag again, drag at the back of the integrator. So to connect to this block, just drag the wire to the back of the arrow, then it connected. If like it goes like this, the red arrow, that means it's not connected. And then to rename this block, you just simply click the block and click the name and rename as inductance. Then enter. So it will be the inductance here. So to adjust the value of this, just simply click the block and place as one. Search it. That means it becomes a moment of inertia of the rotor, this inductance. Then after we rename it, just click the apply and OK. Then we connect it with math operation add math operation add, and drag it and go back out to inductance. Then link it with these two blocks together and click this block and replace this symbol as a positive, negative, positive. That means it will go to three input in here in this block, and apply OK. It's okay if you see this block red because I don't insert any kind of value in it. Because if you want to insert a value, just simply insert here. Okay. Then we go back here. After that, connected with the resistance at up here. So drag again and put it up here. To okay, then after I put a resistance up here, If you want to rotate it, just simply right click the mouse and we go here and flip the block. So we flip that. Then replace the one as a R. Then click apply and OK. And name it as a resistance. Then drag the wire onto the positive symbol here. Okay, then we connected with the source, which is voltage. We found it as a source here and drag this long one. Then drag the wire and rename the block as a voltage. So I will continue to drawing this circuit until I get the result like this. Okay, yes. So these are K, which mean electromotive force constant. Okay, then to insert the value of all of these block, just simply click menu and type motor viscous friction constant V is equal to 0.1. J, which is moment of inertia of the rotor, is equal to 0.01. But be careful. In Matlab, they are very sensitive. The letter always have to be correct when you insert the input, because if you insert the K small letter, it will be an error.
For the automotive.
So let's get back to here, and then we try to run. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil Sulaiman. My matric number is AA191999. And I'm from section 1 for Electrical Engineering Laboratory 2. Today I'm going to explain about the lab activity number 1, which is how to obtain actual response and percentage error. And number 2, how to obtain the graph from the following table. Okay, after we have done put all the component in the Simulink, the diagram will be like this. Okay, so the value for R resistance, L for the inductance, J for the inertia, K and B is present in the command window, and we need to set it by using the value that is given here or here. Okay, so I've put it in here so it will appear in this workspace. This I've been put it before, so this automatically will calculate the value. Okay, so let me start to obtain the actual response. So how we can get the actual response and the graph simultaneously? First, we select all these 3 blocks and we click here and we click the lock selected signal. It will be a little bit different between the Matlab 2015 because I use the 2018 version, so it is like this. So we click on the lock selected signal and this logo will appear in here. Next is we double click the scope and we click view, configuration properties, we go to logging and we tick this log data to workspace and we set the where is the data will be sent. So it go to lab 1, so apply and okay. Okay, next how we calculate the actual response. So we double click the step. For the step time initial value and the sample time, the value has been given in the lab report, so we just use the value and it will not change. The only change is the final value. So first it want the final step value is 1, so we put in here 1 and we apply and we okay, so this stop time just set it for 5 seconds. So we click run. Okay, now we double click the scope, and this is the graph for the final step value 1. We take the value when the DC motor speed is in constant, because when the DC motor start to increase, it is not the actual value, so we need to take when the DC speed is in constant condition. So the value is 0.1. Okay, we key in here 0.1. Okay, next the final step value is 2, so we change the final step value to 2. We apply and okay, and we run. Okay, it has been done run, so we take a look. So the actual response is on 0.2 because it is on the constant condition, so we key in here 0.2. Okay, next is 3, so we just continue to get the actual response by changing the final step value only. So let me continue. Okay, next, how we can obtain the all the graphs simultaneously, which is it as on the question 2. So we have set it to lock and start the selected signal. So we just click here and click the signal key. It will appear here: run 8, run 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, for the run 8, it is the final step value for 1, 9 is for 2, 10 for 3, 11 for 4, 12 for 5, 13 for 10, 14 for 20, 15 for 30, 16 for 40, and 17 for 50. It become run 8, 9, 10 and goes on because I've tried it before. So for the run 8, which is the final step value 1, we click here and we click the DC motor 1. So here it come out with the graph that we get from the scope. And if you click here, step 1, it is the actual value for the final step value, which is 1, but the actual speed is 0.1. Okay, we just untick this. Okay, next we click on the run 9 for the final step value 2, and we will come here to run 10 for final step value 3, which is green, 0.3. Run 11 is for final step 4. Run 12 for final step 5. Run 13, the final step value 10. Run 14 is for 20. Here 20 is become 2. Run 15 for the final step value 30. Run 16 is final step for 40, and run 17 is for actual response for final step 50. So here is all the graphs we have obtained one by one for the final step value. Okay, after we have see the graph, so next how we can obtain the percentage error. So here this is the formula for obtain the percentage error. So actual value minus measured value divided by actual value multiplied by 100. Actual value is actually the value for the final step value or desired response here 1 2 3 4 5 10 20 30 40 and 50, and measured value is the value that we obtain for the actual response, as in here. Okay, 0.1, 0.2, 0.3, 0.4, 0.5, 1, 2, 3, 4 and 5. So we just key in the value into this formula to obtain the percentage error. Okay, so let we calculate the percentage error. So for the first one, for the final step value 1 is okay 1 minus 0.1, which is the actual response. We will get 0.9 and we divide by 1, which is the final step value, and we get the 0.9 and we multiply by 100. So the answer is 90. So 90 is the percentage error for the final step value 1. Okay, so we put in here and we okay, next we will calculate for the final step value 2. So 2 minus 0.2 divided by 2 and 100. So we get the same percentage error, which is 90%. So we put in here 90%. Oh. Okay, next for the final step value 3, and I will continue. I will just calculate it. Okay. Okay, here we have done calculate all the percentage error for the all final step value. So as we can see here, all the percentage has the same percentage, okay, which is 90%. So that's it for the percentage error. Okay, so that's all from me. Thank you.